Okay, so next topic is application of Bernoulli's theorem. Number 1, Venturi-meter. Number 2, speed of efflux. Okay, so speed of efflux or speed of orifice. Okay, so application of Bernoulli's theorem. First thing is Venturi-meter. So this Venturi-meter is to measure the rate of flow. What we will do, we will connect this Venturi-meter in a line where any fluid will be flowing. So using this we will be able to measure how much is the rate of flow or how much volume is passing through that per unit time. Okay, so that is what. So I will draw this, I will explain. Okay, so okay, one side it will have just like this one tube. So here the depth, the volume or area of cross section will be different. Okay, now after that this will be changed and we'll have like this. Again it will come like this. So here again we will have another tube. Okay, another tube. Now here the area is more. Here the area is more. What will be the velocity? Suppose if we consider this point as 1 and this as 2, here the velocity will be v1, here the velocity will be v2, and the area of cross section will be a1, and here the area a2. Correct or not? So then if the velocity there here in this point will be less or more compared to this, less. So here we can write that this is what we are studying now. Okay, v1 is less than v2. Okay, so what about pressure? Pressure about this point and pressure about this point. More. Okay, anyone has any say like pressure will be equal because they are horizontally on the same line? No? Yes or no? No, why? Others? So suppose if I consider this is as a reference, this height and this. Okay, so not because of that. What is the other reason? Here the pressure along the same line, pressure will not be equal. Then whatever we have studied there will be wrong. Then this is dynamic and that is static. Correct. Okay, so only in static fluid pressure will be equal in the same level. In the case of dynamic fluid it can change. Correct. Okay, so the thing is here the velocity is less So here the pressure also will be P1 will be lesser than what? P2. No. Here the velocity is less. Velocity is less means pressure will be more. Here pressure will be less because velocity will be more here. Correct? Right. Now if we draw water or any fluid, if it is flowing like this, okay, now there will be, what will be the, when compared to this tube, whether the height of water column or liquid column will be more or less here? Pressure is more, so that will be more. Clear? Right. So let this be a height. Right, fine. What about this one? Okay, this will be like this. So we are interested in the height difference of this and this. To this one, how much is the height difference? Clear or what? Okay, so note down this one. If you do not know, okay, then we will discuss the velocity and rate of flow also. So in this case, here if I write Bernoulli's theorem, pressure 1 plus half rho V1 square plus rho GH, and this is will be equal to P2 plus half rho V2 square plus rho G again H. So rho GH can be cancelled off. Rho GH can be cancelled off. We could write P1 plus half rho V1 square is equal to P2 plus half rho V2 square. Then we can make an equation of V1 and V2 based on area using what? Equation of continuity. Okay, then after that we can substitute also. Okay, so pressure difference between them, P1 minus P2 will be half rho into V2 square minus V1 square. Correct? Pressure difference between first point and second point is nothing but half rho V1 square minus V2 square. Now based on this height, can I write P1 minus P2 is equal to what? Rho G H also. Here the pressure of this place and pressure of this point, the difference will be what? Only H rho G. Correct or what? Okay, so I am getting like this. So half rho V2 square minus V1 square is equal to rho G H. Correct? Okay, so this rho can be cancelled off. Rho can be cancelled off, and I know that A1 V1 is equal to A2 V2. A2 V2. Clear? Okay, so I can substitute one value here. Okay, just like if we take V2 by V1, V2 by V1 is equal to A1 by A2, A1 by A2. So suppose if I take half, if I take one outside, V2 square if I take outside, this is going to be V1 square minus V2 square is equal to GH. So if I need, I can substitute here half V2 square is equal to 1 minus V1 minus V2 will be a2 by a1. So a2 square by a1 square is equal to gh. Clear? Shall we erase this? So half into a1 square minus a2 square divided by a1 square. Okay. Okay, so suppose if I take v2 square is equal to how can I do? 2gh divided by what? a1 square minus a2 square. a1 square minus a2 square. And what also will be there? a1 a2 a1 square into a2 square also will be there. So v2 is equal to a1 a2 into 2gh divided by a1 square minus a2 square. Clear or what? This is the velocity v2. Same way I can write v1 is equal to what?
a2 square.
a1 numerator. Okay. So a1 square minus a2 square divided by only a1 square will be there. Why it is cancelled off? It will be cancelled off. Okay, so half into v2 square into a1 square minus a2 square divided by a1 square. This is how, right? Okay, is equal to gh. Right, so v2 square is equal to a1 square into gh 2gh divided by a1 square minus a2 square. This is what you are telling. Correct. Okay, thank you. So v2 is equal to a1 into root of 2gh divided by a1 square minus a2 square. Okay, so same way we will be able to say v1 is equal to a2 into root of 2gh divided by a1 square minus a2 square. Okay, so velocity of flow v1 and v2 we will be able to find like this. Okay, now we will see the rate of flow also. Okay, so what is rate of flow? Rate of flow is nothing but a1 v1 same as a2 v2. So suppose if we multiply a1 with v1, what will happen? a1 a2 root of 2gh divided by a1 square minus a2 square. Correct or what? So just see, suppose if we multiply a2 with v2, the same result we will be getting. So this is what is rate of flow. Okay, rate of flow. So using venturimeter, suppose if you know this height, then if you know the area of two tubes also, a1 a2 into root of 2g, this height, okay, not this one or this one, the height difference, divide by a1 square minus a2 square. Merlin, able to get it, right? Okay, Alichami. Clear? Right. P1 P1 pressure here, P2 is the pressure here, so the difference between this will be more pressure alle. Ivide velocity koravalle, velocity koodalaanengil pressure koravu. Okay, area ivide koravaayonde ivide velocity, if velocity is more, pressure is more or less? Less ആണ്. ആ pressure F by A എടുത്താൽ, if area is more, velocity will be less. So area കൂടുതലാണെങ്കിൽ pressure കുറവായിരിക്കും. So pressure, this is what you are thinking. Okay. Let me think. I will explain based on this context how to relate this. എങ്ങനെ ഇതൊന്ന് റിലേറ്റ് ചെയ്ത് പറയട്ടെ എന്ന് സമയം കിട്ടുമ്പോൾ ഞാൻ പറയാം. Okay, now here what you can think is, when ഇവിടെ ഏരിയ എടുക്കണ്ട, ഏരിയയും വെലോസിറ്റി എടുത്തോളൂ, a1 v1 is equal to a2 v2 take, but the thing is like here see Bernoulli's theorem, p plus half rho v1 square is equal to p2 plus half rho v2 square annallo. So here if pressure increases, decrease, correct or what? So for Bernoulli's theorem to be correct, if we increase the pressure, velocity should decrease. So here velocity is less according to continuity equation also. So velocity is less, pressure will be more. That is why we are getting this much height. So that is the reason we are getting P1 minus P2 is equal to rho gh. Now force is equal to pressure by area. So, okay, see, look here, force is equal to pressure into area. Okay, so pressure and area inversely proportional. Okay, so here suppose if we consider in this way, pressure and velocity are proportional, square, correct or what? Pressure is inversely proportional to velocity square, and pressure is inversely proportional to area also. So the trade-off will happen. So in this context we can say Bernoulli's theorem. ആണി അടിച്ച് കയറ്റുന്ന സമയത്ത് വേണമെങ്കിൽ you can consider less area, correct, in order to get more force. Okay, so we'll see that. Okay, fine, clear or what? Done. We will do some problems, or after velocity of reflection, or one problem we'll do based on this. Alikeva? Are you all tired? Tired ayo? AC work agala? അതിന് 30 ഇട്ടേക്കുന്നേ. Okay. Take this question, simple question. Find the rate of flow. Find the rate of flow. Even I was thinking some are giving an awkward look, like just I am not able to understand, no expression at all. So I was thinking like என்னது தொடர்ந்து சொல்ல வேண்டியதானே. Okay, what is the rate of flow? A1 A2 into root 2GH by A1 square minus A2 square, direct. So this is equal to 6 into 4 into 10 raised to minus 8 root of 2 into 10 into 4 into 10 raised to minus 2 divided by A1 A2. A1 square minus A2 square. So 36 minus minus 16. Is it correct? Minus A1 square minus A2 square. So 6 into 10 raised to minus 4 the whole square. Correct? What is the formula? A1 square minus A2 square. 36 into 10 to the power minus 4. Okay, is it correct? 8 8 or minus 4 minus 2 podava. Okay, then so 6 into 4 into 10 raised to minus 8 divided by, so what is this? 20. Okay, so what is the answer? 4.8. 4.8. 48 centimeter rate of flow. 48 centimeter. என்னது 48 centimeter meter cube per second. So this is 4.8 or 48? 48. centimeter cube per second. This is what I have written. Calculation, just take care. 48 centimeter cube per second. This is what the answer which I have written in my notes. Verify the calculation. Okay. Okay, so next topic, speed of efflux or speed of orifice. So that is, shall I erase this? So this is just like, suppose if we have something like this. Okay, so this is full of fluid and a fluid is coming here. This area of cross section is A1 and here we are getting fluid at a V1 velocity. Say for example, here suppose if we have a passage and its area is A2, then if this is coming with the velocity V2, okay, if it is coming with the velocity V2, then with what velocity it is going to come, this is what we are going to see. So suppose if this height is considered as h, okay, considered as h, we write our continuity equation now. A1 V1 is equal to A2 V2. Now the thing is, when this is at this much height, definitely effect of what will be there? Effect of acceleration due to gravity also will be there, no? Acceleration due to gravity also will be there because of this. Suppose this orifice, that is this hole, if it is very small, then compared to this one and this one, this area can be considered as 0. This area can be considered as 0. Otherwise, in the question they will be mentioning the ratio, just like A1 by A2 is 0.2, 0.4, 0.5. If it is mentioned like that, then we should consider that ratio. And what we should do? We should give Bernoulli's theorem here. So P1 there, what is the pressure here? Atmospheric pressure. What is the pressure here? Again atmospheric pressure. Okay, that is there. So suppose if we apply the Bernoulli's theorem, this is going to be P naught plus there half rho V1 square plus, suppose if this height, if we consider as 0, the reference point, that is how potential energy can be learned, right? If I keep here, what is the potential energy of this pen? 0. So if I keep it on the ground, what is the potential energy of this bag? Adu 0, apidu 0. We will consider a point as the reference point. Then we take it as 0 height, then from there we will be taking it as potential energy is equal to mgh. That is how it is. So suppose if I consider this as a reference point, I could write this as rho g what? H. Now this is equal to again P naught plus half rho V2 square plus 0. So P naught if I cancel, and if this velocity, no, okay, if I consider this velocity as 0, okay, since A1 is very much greater than A2, if I consider like that, then this term will vanish. V2 will be equal to rho rho also can be cancelled. This 2 will come here, root of 2gh. So the velocity of a flux is nothing but root 2gh. Okay. This is also called Torricelli's theorem. Clear? Done? நீங்க பரத் தானே?
ஹேமந்த் சார்.
இது
உதய் சார். உதய்.
உதய்.
உதய் பரத்.
உதய் and
ஹேமந்த்.
பரத் எங்க? அது பரத். Clear? Nitish? Clear? Any doubt, children? Copy this.
Under what conditions the fluids may not attain the satisfied Bernoulli's theorems?
புரியல.
Fluids வந்து இப்போ Bernoulli's theorem attend பண்ணாததுக்கு conditions
Oh, that is this fluid will not obey Bernoulli's theorem under what condition? Main condition is if it is not streamline flow, then they won't obey Bernoulli's theorem. Say for example, we have mentioned like suppose if it is kept like this and full the velocity of all these molecules are same. We have made such an assumption before starting this topic, no? Remember, all the molecules in this line will have same velocity. So that is the meaning of actually the streamline flow. But normally it need not be like that. The velocity of different layers will be different. That
turbulent flow, so velocity and pressure may fluctuate.
Turbulent flow means first condition is all the velocities of molecules need not be equal. It will be very rough and just like a flood and just like a tides, how they are moving. So studying about those kind of water flow will be difficult. Still studies are done only, but after understanding all these basics, those people who are specializing in that area, they will be studying about that. Hydroelectric, whatever we do, we will have to do deep understanding about that, all that. So those kind of flows are called turbulent flow. Immediately if we need to understand, when we open the shutter of a dam, how the water is coming out, turbulent flow.
Bernoulli's theorem is not applicable.
We cannot apply, we can apply, but a lot of conditions are there. I do not know about that we don't have to study. So even I do not know. Maybe people who are specializing in that area may be able to comment about it. Clear? So one more thing which I was about to tell you is, see, velocities of all these molecules are same no here. So when viscosity comes, when these layers of water will become different. We will study about velocity gradient that time. Okay, clear? Fine. So what we were discussing, yes, velocity of efflux is root of 2gh. Clear? Now, yes. Suppose if we take an efflux here, and this water is coming out with a velocity root 2gh. Correct or what? Water is coming out with velocity root 2gh. Suppose if it is coming so suppose if this is range, this is range, okay, and suppose if this full height is h, capital H, and this height is small h, can I call this height as h minus h, h minus h? So suppose if I need to find the range, this is actually horizontal displacement. So this is equal to V into time. So this V should be what? Velocity into time. So this root 2gh is horizontal velocity allava 2gh. Munnadi sonna mari, just like previously we have said, S is equal to ut plus half at square, Sy is equal to uyt into ay into t square. No vertical component of velocity, this will come disku. So Sy will be what? H minus h. S minus h is equal to minus layer. Minus potukala. Then we will cancel or nimadi. Minus into half into minus g into t square. So either cancel agum. So what will happen? T is equal to 2 h minus h divided by g. Correct or what? Root kuda. Okay, clear? So if I substitute like this is going to be root 2 into h minus h divided by g. This is also root g, this is also root g. Patak, patak. So this is equal to, range is equal to what? Root of 4 into h minus h into, this is the range of this flow. All these are based on the condition that this area is very much greater than this A2. So we have neglected the velocity here. Clear? Nitish, doubt है Any doubt? Okay. இப்போ வந்து 4 completed. Okay. Now இப்போ for what h na from upper till from the top till this point, from the top till this point, how much is the distance? That is the h we have taken. Correct தானே? So ஒவ்வொரு கான்செப்ட்லயும் வந்து how the measurements are taken, we should have proper clarity. So that is the reason once in a while we go through the derivation and all, because it is important. Okay. So in the height வந்து எங்க இருந்து மெஷர் பண்ணிருக்கு? From where we have measured this? From the top. For what h we will be getting maximum range? We used to say no, range will be maximum for angle 45 degree. In projectile motion same way, I am asking like for what h we will be getting maximum range. So you might have remembering this, you might be remembering since many of you might have studied this already. Okay, so that also I will explain. Okay, இப்போ just like y and x, y is varying based on the change in x, y is varying based on the change in x. So suppose if we draw a graph based on this height, range is varying. Okay, so suppose if I give this height 0, what will happen? Range will become 0. When I put this h is equal to 1, this height if we consider as constant, if this height if we consider as constant, based on this value of height, definitely range is changing. As we already know, if we draw a figure like this, this part what? Slope is equal to 0. Slope is equal to 0. Slope is what? Y minus y1, y2 minus y1 divided by x2 minus x1. So if we consider 2y's here, 0 no? So slope is what? Slope is y2 minus y1 or x2 minus x1. We used to write like this also, dy by dx. Is nothing but slope. So suppose what we do, if we differentiate dr with respect to dh, with respect to what, this value will become 0. Electric field in the ring will become 0 at what length? You have studied, no? So dE by dx is equal to 0. It is equated, differentiated, whatever value we are getting for x in terms of r, no, radius. That is how the same concept here. So what we do is we will differentiate range, which is nothing but 4hh minus h square in this way. Clear? So when we do this, what we will be getting? Okay, 4h minus 2h, no? 4h minus 2h. Oh, okay. 1 by 2 is there. So what we will do? Okay. Into 4hh minus h square into common. Okay, 4 is common for both. Okay, right. Okay, so this is nothing but d by dh of, this is going to be all raised to 1 by 2. This is actually 4hh minus 4h square. This is what, so we will differentiate each one. So dh, okay, we'll do it like this: 4hh minus 4h square all raised to minus 1 by 2 into 4h minus 8h. Okay, this will be equal to 0. This will be equal to 0. Okay, so if we do like this, then what value we will be getting for this small h based on this h? Can you see? We will be getting the small h is equal to h by 2. H by 2. Clear? So range will be maximum. Range will be maximum for this h is equal to exactly in the middle of the total height. Okay, clear? So this is the details about speed of the flux. Speed of the flux is nothing but root 2gh, and the range is nothing but root of 4 into h minus h into h, and we will be getting maximum range at height is equal to total height divided by 2. Second question, find the velocity of outflow of liquid from pump. Second question in the handout, find the velocity of outflow of liquid from pump if the piston moves with a constant velocity under the action of a constant force. The density of liquid is rho. What is the velocity of outflow? Any answer? 2. Option 2. Getting all of you? Try option 2. Okay, so right. So here we are applying a force. The same time here atmospheric pressure also will be there. Correct or what? Then in this place pressure P naught will be there, and this will be coming out with some velocity. Say for example, suppose say if that is V2 and here if it is V1. Okay, and the center of this and the center of this, they are both at the same height. So we need to consider only what? Bernoulli's theorem, P naught plus half rho V1 square plus. So this is going to be what? P naught plus what? Force is also there. So F by A. F by A. So and this side, this is going to be P naught plus half rho V2 square. Half rho V2 square. Clear? So this P naught we are cancelling. One more thing which I am doing, since this area and that area, what is not given? Area comparison ratio, nothing is given. So I am neglecting this to 0. Okay, so if I do like this, F by A is equal to half rho V2 square. So V2 is equal to 2F A rho root. Is it correct? Fine.
டி நம்ம போட்டிருக்கோம் சார். டீங்கிறது இங்கேருந்து இங்கே வரைக்கும் எவ்வளோ டைம் எடுக்குது,
அதுதான்.
அப்படி இந்த மொத்தமாக காலியாகனா எவ்வளோ டைம் எடுக்குது அப்படி கேட்பாங்க.
அதுவும் கண்டுபிடிக்கலாம்.
அது எப்படி கேட்பாங்க?
I will tell you now. Clear this one? Come here.
Density below in this format.
Density is equal to mass by volume, mass by area into height. Which area into is equal to mass by volume? Which density we are finding now?
Sir, this formula for exams of taking from this.
Oh, for this one. Right, okay. But okay, then
H is equal to m by rho. I'll check it.
okay, I'll tell you. We cannot apply like that because G is separate. G is completely acceleration due to gravity. That is a constant value.
பதிலாக தானே சார் நம்ம ஜி போட்டோம் அந்த இடத்துல.
ஏக்கு
சார் கொஸ்டின் நம்ம டெரிவேஷன் வீட்டில் போடும்போது ஏக்கு பதிலாக தானே சார் ஜி போட்டு சால்வ் பண்ணணும். அது ஏனே வச்சு இருந்துருக்கலாம் அப்படி.
which A?
ஜிக்கு பதிலாக ஏனே வச்சுருக்கலாம்ல சார். ஏன்னு வச்சா அப்போ எஃப் பை எம்.
But here in this case, no, already that acceleration due to gravity is present, no. And the acceleration currently here means the acceleration present in this context is G. So that acceleration we cannot replace with the force by mass. Somehow you got the answer, but that is a luck. That is a luck. Okay, fine. See, children, understood? Okay, so okay, another question. Third question. A large open tank has two holes in the wall. One is a square hole. Okay, question number 3. Large open tank has two holes in the wall. One is a square hole of side L. Okay, so this is a square hole, okay, of side L at a depth y, from the top, and other is a circular hole. Other is a circular hole with a radius r and which is at a depth 4y from the top. When the tank is completely filled with water, the quantities of water flowing out per second from the holes are the same. Okay, they are same. That is water flowing out per second means rate of flow are same for both. Then R is equal to, in terms of L, large tank they have said, very large tank they have said. Okay, so okay, so rate of flow are same for both, rate of flow are same for both. So can we write A1 V1 is equal to A2 V2? So this one A1, suppose if this is A1, can we write this is L square into root 2G, what is the H here? Y. And this is going to be pi R square into root 2G what? 4Y. Okay, so this 2G, this 2G, this Y can be cancelled off. So L square is equal to pi R square into 2. So finally what we will be getting? R square is equal to L square by 2 pi. R is equal to what? Root of L by 2 pi. L by so this is going to be L by okay, thank you children. So the formula for time to empty the tank, okay, the formula for time to empty the tank. So the tank will be empty if we have the hole at the bottommost point, correct or what? Here if we put the hole, then only tank will become empty. Okay, so the formula is A by A. So A is this area, and small a is the area of the orifice, and this is root of 2h by g. H is the total height. So mark this also, so that if you get any question, you will be able to answer this. The ratio of cross-sectional area, okay, this is also given, A and this area, okay. Suppose if this is A, the ratio of cross-sectional area of orifice to that of tank, that is A by A, is given as 0.1, okay. Then find V square, okay, find V square. Which V square? This V square. So this time the area is not negligible. This area we cannot neglect. So the thing is V is equal to root 2 GH. That liberty we cannot use here. Okay. So a different question. This area is given. Got the answer? Clear or what? Getting the answer? Okay children, so V1 is equal to 0.1 V, that is this velocity will be equal to 0.1 of, so V1 can be written like a V by 10. So when if we apply the Bernoulli's theorem, here the pressure is P0, here also the pressure will be P0. So P0 plus rho G, okay, so this height is also given, this is also given. So okay, here go to rho GH, okay, rho GH1, okay, plus half rho what, V1 square. This is equal to P0, this here whatever be the pressure P0, plus half rho V square plus rho G H2, So P naught can be cancelled out. Now the thing is V1 based on V we have. V1 based on V we have, correct or what? This if we can substitute there, then H2 is what? Suppose if we consider this as the reference, we can take this height and this height also. So if we simplify this, what answer we will be getting? Should I give you the options? Okay, take these options. 50 meter square by second square. B is 50.5 meter square by second square. C is 51 meter square by second square. D is 52 meter square by second square. 52 meter square by second square. That is the answer you are getting. Okay, any other answer? Okay, so let us see if we put this as the reference. Okay, this as the reference we will take. Okay, this as the reference height if we take, then one thing will become 0. So let us do that. So this will become 0 if we put that as reference height. So half rho V1 square, what should I put? V square by 100 I will put. Okay, fine. Okay, right. Okay, so this one we will get. Okay, right. Fine. Okay. Okay. Okay, thanks for help. Okay, so half rho V square by 100 rho G H1 plus is equal to half rho V square. Okay, so rho G H1 is equal to half rho into V square minus V square by 100. We can take this. From this, rho and rho can be cancelled off or what? Is it okay?
Yes, sir.
Right. So here what will come? This will come here. 2G H1 is equal to, this is 100 minus, so 99 V square by 100. Okay, so V square is equal to 100 into 2G H1 divided by 99. Now we will put the values 100 into 2 into 10 into H1 is how much? 2.475, right? So this is 99. Okay, then calculate this. 50 meter per second. Okay, what you are getting? 52. So what I got is 50 meters square per second square. Okay, 50 meter square per second square. So this is the answer. So this is one question where the ratio is given. So when ratio is given, we will have to do all the way like Bernoulli's theorem. This question, this calculation is coming just because this is a JE question. Okay, this is a JE question. So JE question usually will have this. Okay, many questions will have lot of calculations. Okay, children, understood or what? Okay, just calculate it again. I have taken that. If I want, I can take this as reference point. So the thing is like rho G H1 will be this height. I will have to put rho g h2, I'll have to put this height. Then again this will make the calculations complex. So what we have taken, this height is taken as the reference point, and just one thing we have threw away. That is how. For Bernoulli's theorem always we are measuring from bottom. Bernoulli's theorem always we have measured from the bottom. Do you remember this figure? This height is h1 and this height we have measured as h2. So in Bernoulli's theorem we have taken like that. That is the reason we are taking the height like this. But in velocity of flex 2gh we have taken from here. This height we have taken root 2gh. That is the reason we are taking like that. Clear? Okay. So this most of the problem regarding this speed of flex we have done. Okay, you can practice more. Okay, you can practice more, you can be stronger in that. Okay. Okay, so we'll start viscosity. So when we study viscosity, viscosity is nothing but the friction. Viscosity is the friction between the liquid layers. Okay, viscosity is the friction between liquid layers. So suppose if this is a river, liquid layers will be what? Very close. Liquid layers will be just small layers. Suppose if we zoom those layers, zoom. Okay, so this is first layer, second layer. Likewise, we are able to see this, okay, separately. Now suppose if this is river bed. Suppose if this is river bed. This first layer, if it has a velocity of 8 meter per second, second layer can have a velocity of 6 meter per second, then 4 meter per second, say 3 meter per second, 2 meter per second. Likewise, it reduces. Finally, the layer just above the river bed will be 0. Now suppose if this distance is 2 meter, this distance is 2 meter. Likewise, if we separate them, velocity gradient means the change in velocity with respect to distance, So likewise, this need not be uniform like this. 8, next layer will be 6. No, it need not be like that. It can be in different numbers. This could be 8, this can be 5, likewise different numbers. So this is called a velocity gradient. Velocity gradient. Clear? So this viscosity depends on velocity gradient also. Viscosity depends on velocity gradient. And we know, suppose in NLM, Newton's laws of motion, if the particle is moving in this direction, viscous frictional force will be moving in the opposite direction, and we used to have what? Coefficient of friction also, mu. Likewise, we have velocity gradient. At the same time, different fluids will have, okay, coefficient of viscosity also. Clear? So velocity gradient, coefficient of viscosity. Okay, now here the area of this thing, will it make any difference in the friction in Newton's laws of motion? No. Correct or what? In this case we are going to discuss that also. Okay, suppose a plank a plank or a boat, when it is moving in water, okay, suppose if this is water, okay, if a boat, if it is moving, okay, so how much viscous force will be experienced by this boat? All these things we will study now. Okay, so just mark this velocity gradient. Okay, clear? All these things understood or what? Okay, so those who do not know, please mark this. Okay, so this velocity gradient we say dv by dz. Okay, velocity gradient is dv by dz. This is coefficient of viscosity. Then as I said, the area of the thing which is in contact, okay, area of the body, all these things decide the force of viscosity, viscous force we say. Then okay, so viscous force is proportional to velocity gradient, and this is proportional to the area in contact. In this case, which is not there in generally friction, but here, that is in viscosity, area is also a matter. Then minus of coefficient of viscosity A dv by dz. This is the viscous force. Okay, this is the viscous force. That's it. So this viscosity depends on the material. Viscosity depends on the material. This coefficient of viscosity, okay, depends on material. Material means which fluid, okay, water, okay, then tar, we know on the road we put tar, grease, oil, everything will have different viscosity. Okay, then this depends on what? Temperature. Okay, so when you heat the tar, it will become less viscous. What will happen? Those people will pour it on the road. Then once it is cold, that will become very strong. So if it is possible, if you put a metal metal hand covering, and if you are putting inside the tar when it is hot, suppose, then if you put off the fire, and if you talk, and if you try to bring it up, is it possible? It will be there forever. Correct or what? So depends on the temperature. Depends on the temperature also. Clear? What will be its unit? This is force. FV is force, so its unit is Newton. Fine. So now we are interested in finding the unit of coefficient of viscosity. So if we take coefficient of viscosity, this eta is equal to what? FV into dz by dv into divide by A. Correct or what? FV into dz divide by dv into A. So this is actually Newton, this is meter, this is actually meter per second, and this is going to be meter square. Suppose this meter if we cut, this is going to be Newton second per meter square. So this is the unit of viscosity. Okay, unit of viscosity. Clear? So if we put a dimensional formula, mLt raised to minus 2 into this is going to be T, and this is going to be L square. So finally what we will be getting? mL raised to minus T power minus 1. This is the dimensional formula of coefficient of viscosity. So then another unit which we used to get in the questions and generally which we see is poise. So 1 Newton second per meter square is how much poise? 10 poise. Okay. Okay, elasticity we are going to study. Okay, maybe tomorrow or day after tomorrow. So in that, what is shearing stress? You might be knowing no already. Tangential. For stress is actually force by area. Stress is actually force by area. So shear stress is what? Tangential force divided by tangential area. Okay, what? Simply if this is a structure, then tangentially we will be applying force. That's it, right? No. Okay, right. So shear stress, we have idea about it. Okay, already we have studied it. Okay, take this question. Okay, take this question. Suppose this is just a stream of water. Say this is 5 meter. Okay, 5 meter. The viscosity of this is 10 raised to minus 2 poise. 10 raised to minus 2 poise. 10 raised to minus 2 poise. This surface water, okay, this is surface water. This is moving at a velocity of 18 kilometer per hour. Okay, 18 kilometer per hour. So this is river. So the lowermost layer of water is at rest. Okay, riverbed, lowermost water is at rest. Clear? So find the tangential or shearing stress among the layers. Okay, so tangential or layers. This is the question. Okay. How much is the viscosity or coefficient of viscosity will be how much? 10 raised to minus 1. One Newton second per meter square is equal to how much? 10 poise. So 1 poise is equal to 0.1. How much poise is here? 10 raised to minus 2. 10 raised to minus 2 poise. 1 poise is 0.1. So 10 raised to minus poise will be how much? 10 power minus 3. Okay, so this is going to be 10 power minus 3. Okay, be careful. Now the things are easy. So viscous force is equal minus eta A dV by d. What they are asking? Tangential force by area. Correct or what? Or tangential. So anyway, viscous force is acting tangentially or what? Viscous force is acting on the layers. So can P by A is equal to minus eta dV by dz. Can I write like this? Okay. dV by dz is how much? Here it is 0. So dV is nothing but 18 minus 0, 18. Okay, so 18 kilometer per hour. So into 5 by 18. Divide by dz is this distance. So this is going to be 5. Pada 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 1. Okay, 1 over. So this is going to be minus 10 raised to minus 3 into 1. So the answer is going to be 10 raised to minus 3. Okay, clear. So this is Newton per meter square. Okay, now how much force of viscosity a body will experience when it moves through the liquid? So clear, that is the topic which we will discuss now. Clear? Shall I erase this? Okay, so okay, so viscous force experienced by body on fluids. So number 1, surface level. Surface level. Okay, if something, one wooden plank or boat or ship, it is moving through the surface, how much viscous force it will experience? Okay, so that is the first case. Okay, so this is case 1, surface level. Case 2, okay, inside the fluid. Inside the fluid. Clear? Correct? Clear or what? So shall we will do one question. There is nothing more to explain there. Okay, the same viscous force we will apply. So I will give you a question, from there it will be clear. Okay, see, a stream of water. Okay, suppose if its depth is going to be 1 meter and okay, something is going on it. Okay, something is going on it. This is moving at a velocity 10 meter per second. Okay, and this is this river bed, the last layer is at rest, V is equal to 0. Okay, then area of the body which is in touch with the river or the stream is given as, sorry, this you can make it as 2 meter per second. This is actually 2 meters square. Okay, 2 meters square. Okay, and the viscosity of this is given as 10 raised to minus 2 poise. 10 raised to minus 2 poise. What is the depth? 1 meter, right? Now find the force required to keep the plate in uniform motion. So the question is, find the force required to keep the board in uniform motion. So find the force required to keep the board in uniform motion. So what we are discussing is the case 1 of this.
What will be the direction of viscous force?
Direction of viscous force will be, suppose if the boat is moving in that direction of viscous force is in, if the boat is in that direction, the direction of viscous force will be in this direction. Mattu force viscous force opposite ah irukum. Na Chennai போறேன்னு சொன்னீங்கன்னா அவங்க என்ன சொல்லுவாங்க, வேண்டாம் பாலக்காடு போங்கன்னு சொல்லுவோம். நான் பாலக்காடு போக போறேன்னு சொன்னீங்கன்னா வேண்டாம் சென்னை போங்கன்னு சொல்லுவோம். அந்த மாதிரி கேரக்டர். Okay, clear? So how to find this? What is the answer? See, the crux of Newton's laws of motion is what? In order for a body to be in uniform motion, or for a body to be at rest, no force is required. Friction, since friction is there, we are applying force to move the car to move at maybe 5 meter per second. Suppose if the car or bike is moving at 5 meter per second, friction is there in earth, air friction is there, okay, body friction is there. That is the reason we have to apply force. Suppose if there is no air, no friction, if it is in the space, okay, just look at the videos of the spacecraft. If you have something is there, if they throw something like that, this will start going, then they will have to catch from there. Okay, so suppose if our task is to put the thing on the orbit, then it will move. Satellites or something, if we launch, no, so that if we put in the orbit, put in the place, then remaining things we don't have much worry, it will move. To move again, escaping from the earth's gravitational field and friction, all these things are our headache. So escape velocity, all these things, if it can cover in the space, to move in a uniform motion, no force is required. Something, if it is moving in the uniform motion, it will keep on moving. So here, to maintain the uniform motion, since friction, viscosities are dealing against it, we will have to apply what? Force. Clear? So whatever be the viscous force, that much force we will have to apply so that it will be moving with the uniform motion. Correct or what? Aristotle's fallacy, Galileo's findings, all these things are saying this only. Clear? Any confusion? Right. So the same thing here. So Fv is equal to what, children? Minus eta A dV by dz. So when poise is 10 raised to minus 2, in SI unit how much it is? 10 raised to minus 3 into area is 2 and dV is how much? If this is moving at 2 meter per second, the molecules under this also will be moving at 2 meter per second, and this is going to be 0. So dV is nothing but 2, dz is nothing but 1. Okay, so this is the 4 into 10 raised to minus 3 is the viscous force. So same external force we will have to apply so that this is going to be moving with the uniform velocity. Clear? Minus, here minus is there. Here minus is there, here no minus. Okay, another question. So here area in contact is 1 meter square, mass is 2 kilogram, this is moving at 10 meter per second, a force is acting 2 Newton, this depth is actually 1 meter, okay, so river bed velocity is equal to 0. So imagine this is a toy boat. Okay, in a toy boat we have taken a container full of water and a toy boat is there. External force is acting. External force we are applying 20 Newton. This is moving at a 10 meter per second. Mass of this is 2 kilogram. Okay, so eta viscosity is 10 poise. 10 poise. Okay, find the acceleration of boat. So find the acceleration of the boat. These are the options: 10 meter per second square, 5 meter per second square, 2.5 meter per second square, 1.25 meter per second square. Yes. So when in Newton's laws of motion also, a pulley will be there, block will be there, something will be there. They will be asking, you know, what is the acceleration of this block? So the question is, what is the acceleration just now? That is the question. That is the meaning of the question. Otherwise, what will happen? This block will come and it will dash the pulley. Everything will fall down, right? So at that moment, what is the acceleration? That is the real meaning of this question. Correct? So this also, what is the acceleration of the board when this present condition is there? That is the question. What is the answer, children? 5 meter per second square. Okay. So external force is in this direction. Viscous force is in this direction. So our F net is equal to what? F external minus Fv. So acceleration is going to be net force divided by mass. Okay. Now what is Fv? Minus eta A dv by dz. So minus 1 ilya into area is 1. dv is how much? Divide by 1. Ellame 10. Ellame 1 na. 10. Right. F external is given as 20 Newton and viscous force is going to be 10. This minus 10, it is to indicate this direction. Again if we put minus, no need. So this is going to be how much? 10 Newton is the F net. So 10 divided by how much is the much? 2. So this is going to be 5 meter per second square. Clear? These kind of simple things, not much. Clear? So this is about case 1. This is about case 1. Next is case 2. Shall I erase this? Completed? Okay. Shall I erase this one? Okay. Okay, so suppose if this is the fluid, okay, a body will be moving through the fluid, and the body which we will be studying is only sphere. We are going to study only about sphere which is moving through this thing. Okay, so this is called that thing which explains this is called Stokes theorem. Okay, this case 2 is dealt by the theorem called Stokes theorem. So the thing is, the viscous force okay, so the viscous force acting on a body moving through the fluid depends on, okay, number 1, size of the body, shape of the body, size of the body, shape of the body, okay. Third one, viscosity of the liquid. Okay, so in this case the viscous force is 6 pi eta RV. In this case means we are studying only about spheres. So this R is radius of the sphere. This formula we derive using dimensional analysis. Using dimensional analysis only we will be deriving. So radius of the sphere, this is nothing but velocity of its movement, velocity of the body. This is the viscosity of fluid, viscosity of the fluid. Okay. Okay, now see, suppose this is a question. Okay, take this as a question. A question, suppose inside a fluid a body is moving. Okay, suppose if it is this is moving with a velocity 10 raised to 3 meter per second, 10 raised to 3 meter per second, and its radius is 0.5 meter. Its mass is equal to 6.28 kilogram. Okay, and the viscosity is 10 raised to minus 3 Newton second per meter square. Okay, find the acceleration of the object. Find the acceleration of the object. 0.5 meter per second square, 1.5 meter per second square, 2 meter per second square, 3 meter per second square. 1.5. So acceleration is equal to 6 into 3.14 into eta is how much? 10 raised to minus 3 into radius is 6.5 into what then? 10 power 3 divided by mass 6.28. So suppose how much we are getting pa? 1.5 meter per second square. So force by mass we have done. Okay, now is it possible for us to find this acceleration? Suppose if we get s distance and all, s is equal to ut plus half at square, or v is equal to u plus at, or something like that. If some distance is given, say for example this is moving for such a distance, then is it possible for us to find? And what I am asking is v is equal to u plus at, or v square is equal to u square plus 2as, or s is equal to ut plus half a square. If this can I use this equation? Say for example, if the body reaches here, the velocity will become what? 0.5 into 10 raised to 3, and if I give this distance as 10 meter, then is it possible to find using this one? Suppose see 0.5 into 10 raised to 3 is equal to, okay, this square is equal to what? 10 raised to 3 the whole square plus 2 into a into 10 meter. Only one unknown is a. Is it possible to find? Objection? Objection? Any objection? Objection is there. Objection is there. Acceleration is very. So we cannot use this. We cannot use this. See, where is the force? So force is there. Force is equal to 6 pi eta r v. So there is ego between these two people. Okay. When force increases, velocity will increase. When velocity increases, again force will increase. So this velocity, this force, this acceleration, they are not constant. Only for constant acceleration we can use all these equations. Correct or what? So here we have variable acceleration. What I have asked here, it is instantaneous acceleration. Instantaneous acceleration means what is the acceleration? We used to ask, no, what is the acceleration at a time t is equal to 2 seconds, no? In motion in one dimension, what is the acceleration at a time instant t is equal to 3 seconds, 2 seconds, likewise. So here the question is, what is the acceleration when velocity is equal to 10 raised to 3 meter per second? So that moment when velocity is equal to 10 raised to 3 meter per second, for that moment alone, this is going to be 1.5 meter per second square. In the next moment, what will happen to the velocity? Velocity will become 10 raised to 3 plus 1.5. Well, that will become the velocity. Then again what will happen? This force will change. Again acceleration will change. So acceleration keeps on changing, velocity keeps on changing, force keeps on changing. We cannot use this method. Okay children, done? Okay. Okay children, so now put the heading terminal velocity. Okay, so terminal velocity, suppose what is this? This is air, okay, and this is raindrop. Okay, so here before what we used to get, the solid will be moving through the fluid, so density of solid is more compared to the fluid. Now we consider air as the fluid, and this water drop, it is having more density compared to the air. When this is coming down, there is going to be mg acting down, there is going to be upthrust acting upwards, and what also will be there? Viscosity also will be there. So this viscosity is nothing but air friction. So this is coming down. So when it comes down, what will happen? mg is more compared to Fv and U putting together. mg is more compared to F and U putting together. Correct or what? This is coming down with acceleration. So when this acceleration is more, what will happen? Again, this velocity will change. Will there be any change in the upthrust? This upthrust is going to be how much? V rho of air into G. So velocity, volume of this drop, density of the air into G. And what is Fv? 6 pi eta Rv. And is going to be what? V, density of the drop, V rho G, correct no? Into what? Okay, so that is mg. So what will happen is, whenever this mg is greater than Fv plus upthrust, this will keep on coming. Okay, so every time what will happen, since there is acceleration in this direction, force in this direction, this velocity will slowly increase. Velocity will keep on increasing. At one point what will happen? This upthrust, this Fv and this mg, they will come in equilibrium, because only this is varying. When net force is zero, actually there is no force. When net force becomes zero, then this experience no force. So that time what will happen? There is no scope for this force to change. This will become constant then. Clear or what? Okay, so at when mg is Fv plus U, what will happen? So in this case Fv is variable. Okay, so this will be increasing. U and mg are constant. So what will happen when mg is equal to viscous force plus U? when this situation comes, okay, what will happen? We can say F net is equal to 0. So V in F is constant. This will become constant. So finally what will happen? FV will constant. So raindrops starts coming down with uniform or constant velocity. This is called terminal velocity. Clear or what? So this is called a terminal velocity. So this is the sole reason that we are able to play in rain. Okay, we are able to play in rain, right? We can move around, we can play. Otherwise, just like a bullet, one raindrop, over. Situation will come. Correct? So this is the what? Unique brilliance of the intelligence behind the creation of the world. We can see God's hand in each and everything actually. Otherwise we won't be able to live in the world. Because of friction only we are able to walk. Because of friction only we are able to construct buildings. Otherwise nothing is possible. First man will come, he will die there. Nothing will happen after that. Okay? So this is terminal velocity. Okay, note it down. So mg was greater than fv and u. So it was coming, since it is coming with the acceleration, since it is coming with the net force, there was change in velocity which is present in that viscous force. Finally what happens when viscous force is increasing? Finally a stage will come, fv plus u will be equal to mg. Okay. So what will happen? The volume of the drop, okay, into g this is equal to 6 pi eta rv. Here I am putting this t. Once this is equal, then that is the terminal velocity, that will be the last velocity which is possible. Okay, plus upthrust. Upthrust is nothing but again same volume into density of air into g. Clear? Clear or what? So now what we can do? 6 pi, okay, we can write in this way, Vt is equal to V rho g. Okay, so this is density of drop, correct? So density of drop, we will write like that, V rho g minus V rho of air into g, divide by 6 pi eta r. Is it correct? I could write this Vg I am taking out. This will become density of drop minus density of air divided by 6 pi eta r. Terminal velocity is equal to. So this is spherical, na? Spherical drop. So terminal velocity is equal to, I can put 4 by 3 pi r cube. So r is the radius of that sphere or drop that is coming into density of drop again minus density of air divide by what I have, 6 pi eta r. Clear? So this pi can be cancelled, this r, this can be cancelled, r square, correct or what? Right? Then this will become 2, this will become 3, correct or what? Fine. So G is missing. So this is going to be 2 by 9 r square G density of drop minus density of air divided by eta. This is the formula for terminal velocity. So here you can generalize density of drop can be considered like a density of solid. This density of air can be considered like a density of liquid. Okay, so whichever is having more density and whichever is coming as sphere, so that will come here. Through which fluid, whether it is air or liquid or whatever it may be, even payasam adnalum, that we should put here. Correct or what? Done. Terminal velocity. ஒரு question தரவா? Sphere P, this is another Q, density of the solid it's equal to 8 gram per centimeter cube. Here the density of the solid is again 8 gram per centimeter cube. Diameter is equal to 1 centimeter. In here diameter is 0.5 centimeter. Viscosity, coefficient of viscosity, here it is 3, here coefficient of viscosity is equal to 2. Density of the liquid in this case is 0.8 gram per centimeter cube, and here density of the liquid is equal to 1.6 gram per centimeter cube. Okay, so the question is terminal velocity of P divided by ratio of terminal velocity of P. This is the question. Option 1, 2, 3, 4. 3. Any other answer? So what is the formula for terminal velocity? 2 by 9 r square g density of drop minus density of air or fluid, divide by what? Eta. So this is the formula. So terminal velocity of T will be what? So here what all constants are there? 2 by 9 can be cancelled, no? T also can be cancelled. So eta is different, no? Eta is different, diameter, all those things are different. So whatever is required, that we will take. So for P, diameter is 1 centimeter. So 0.5 centimeter square we will put into density of that solid is what? 8 gram per centimeter cube minus what is the density of that liquid? 0.8 gram per centimeter cube, divide by what? Eta, which is going to be 3. Okay, so this divide by what? VTQ. So what we shall write here? Diameter is again 0.25 centimeter square and density of drop is here 8 gram per centimeter cube minus here the liquid has 1.6 gram per centimeter cube, divide by what? 2. Clear? Okay. So that's it. So here this one if we cancel, what will be getting? Okay, 0.25 centimeter square and this is going to be 0.5 centimeter square. So how to calculate this? Okay, so 0.25. Okay, so this is going to be how much? 0.5 centimeter square into 0.5 centimeter square, divide by 0.25 into 0.25. 2 will be getting there, no? So here this will become 4. This 3 will be there. This 2 can be put there. Okay. Now what about this one? 7.2. What about this one? 6.4. 6.4. So if we calculate this, what you are getting? 3. Yes, 3. This is the correct answer. Okay, that's it. They asked this in advanced actually. This is a JEE advanced question 2016. Okay, so just approach in the smart way, things will be easy. Clear or what? Fine. If we plot, okay, copy this. Shall I erase this, children? Fine. So time, terminal velocity. Okay, so terminal velocity will happen. Finally, what will happen? It will become constant. Okay, so velocity will be increasing. Actually, we can say this is v, and when this becomes constant, this is what is terminal velocity. Clear? Okay, clear? All right, children. So whatever we have studied so far in fluid mechanics, so with this fluid dynamics is done. Fluid dynamics is done. Now tomorrow we will see surface tension, surface energy, capillary rise, all those stuffs. Okay, so far whatever we have studied, okay, Just engage with me. Okay, you start. Okay, what is the pressure difference vertically? H rho g. Okay, what is the pressure difference horizontally? 0. If it is accelerating upwards, what I am asking, if it is accelerating upwards, pressure difference pressure difference will be H rho g plus A. If it is moving down, pressure difference between H rho g minus A. If it is accelerating rightwards or leftwards, L rho A. Pressure difference is going to be L rho A. What is the angle of inclination? Tan theta is equal to H divided by L. The relation between H divided by L is equal to what? A by G. Okay, then what else we have studied after that? Buoyancy, Archimedes principle. So buoyancy is what? Upthrust. What is that volume? What is that formula? What is upthrust? V im rho L G. This is what is upthrust. Then this upthrust is nothing but volume of the liquid displaced. Volume of the liquid displaced. That is what is Archimedes principle. Law of flotation. 3 cases are there. One thing, it will completely go down. There we are interested only in finding the apparent weight. W apparent is going to be mg minus u. Second case and third case, where either density of the solid will be equal to density of the liquid, it will be completely submerged and it will be floating neatly on the top of the water. Another case is density of the solid will be less than the density of the liquid. A part will be outside the water. In both the cases, W apparent is going to be, one thing is completely 0. One thing is 0. Another thing, both the cases, one thing is sure that it is floating there with at equilibrium. So upthrust will be equal to mg we can do. Upthrust will be mg we can do. When it is equally submerged, then what will happen? Apparent weight will be 0. Okay, apparent weight will be 0. Clear? Any confusion there? Weight mass mg, okay, will be equal to volume of the solid, density of the solid into g. Upthrust, the difference is here volume, whatever is inside the water, into density of the liquid into g. Okay, law of flotation. We have done a decent problem. Okay, a half of the thing is inside, okay, and it is accelerating upwards. In all those things, okay, we will have to take the effective acceleration we have done, right? So with that, fluid statics is over. Then we came to fluid dynamics. First thing we have studied is equation of continuity. A1 V1 is equal to A2 V2. Done. Another thing is Bernoulli's theorem. Pressure energy plus kinetic energy plus potential energy will be constant, or otherwise pressure plus half rho v square plus rho gh will be constant. Application of this is nothing but Venturi meter. Rate of flow will be equal everywhere. What is rate of flow using Venturi meter? A1 A2 into root 2gh by A1 square minus A2 square. Next thing we have studied Flex. So in Flex, what is the velocity? Root 2gh. When the first area is very big compared to this one, if any ratio is given, then we will have to apply Bernoulli's theorem. Okay, we have done a problem also on that. What is the range? Root of 4 into capital H, full height, minus small h, this height. From the hole, how much to the top? That height. So root of 4 into capital H minus small h into h. That is the range. Where is the maximum range? When we keep the orifice exactly at the middle of the total height. Clear? Then what is the time at which the water will become empty? A by A means capital A by A or small a by A? Capital A by A into root of 2h by g. Done. Over. Then what we have studied? Viscosity. So what is the viscosity formula? Viscous force F is equal to E minus eta A dv by dz. dv by dz is the velocity gradient, change in velocity by change in distance. Okay, change in velocity by distance. Okay, then area is the area of the surface where the boat or any plank or any wood it is in contact. Okay, then what? If it is moving inside, then Stokes theorem. What is that formula? Force of viscosity 6 pi eta rv. 6 pi eta rv. Then we came to terminal velocity, upward force, buoyant force, then upward force, viscous force, raindrop is coming, mg downward, buoyancy upward, viscous force is also upward. This viscous force depends on velocity. If acceleration is there, force is there, velocity will be increasing, viscous force will be keep on increasing. So here one point will come where mg UFE, everything will become equal. Upward force will be equal to downward force, then terminal velocity will come, so that this raindrop will come with the constant velocity. This is applicable for raindrop, this is applicable for solid which is moving through the liquid also. What is the formula for terminal velocity? 2 by 9 r square g, rho of solid minus rho of liquid divided by eta. Okay, so that is terminal velocity. We have done problems also. Fine. I hope everything is clear. So revise today itself. Okay. Tomorrow we will discuss surface tension and other stuffs. Okay. So thanks for your patience. Thank you so much.